Blaise Pascal, Legacy. So this is going to be everything about Pascal, the triangles, his inventions, his life, and hopefully you'll find it interesting. Early life. Blaise was born in 1623 in France, and along with his sister Jacqueline, they were both child prodigies. Blaise was a writer and inventor, a physicist, a mathematician, and a Christian philosopher. At the age of 16, he corresponded with the mathematician Pierre de Fermat on the probability theory, which helped the fields of social sciences and modern economics. La Pascaline and the modern PC. La Pascaline. Pascal invented the mechanical calculator at the age of 19, in 1642. He did so to relieve his father, who was the supervisor of taxes in Rouen, of the burden of manual calculation. It remained the only mechanical calculator for 40 years. And what's interesting about this is that the King of France had it trade patented, so no one else was able to replicate it until then. So, how did this lead to the PC? Well, for over 247 years, Pascal's original design was left relatively unchanged, but it led way to the invention of the comptometer, which is what we call today the calculator, and that led to the way for the first modern computers. Oh, de la Pascaline. Oh, Pascaline, how I think of you when I compute. Almost 400 years since you've come along. Smitten I am with all your feats. Calculating no longer takes forever. Arithmetic is much more quick. Lovingly, I pressed your keys. Intuitively, you know the answer to all my problems. Numerals now symmetrical. Enumerating sums since 1642. Pascal also was a Christian philosopher, as I have stated previously. So, what is Pascal's wager? Well, after his father's death, Pascal had a religious calling and stopped most of his work in the field of science and mathematics. He then attempted to prove mathematically that one should be a Christian and believe in God. His proof is called Pascal's wager. Pascal believed that if God existed and one believed in God, then there would be an infinite gain. If they did not believe in God, but God existed, there would be an infinite loss. If God did not exist, but one believed in God, then the loss would be finite. While if one did not believe in God, but God existed, then the gain would be finite. So, what I've just stated is now expressed with the decision matrix. And Pascal deducted that one should rationally believe in God, as it is demonstrated here. To find the probability of choosing the right God or the right choice, Pascal used the formula P equals 1 over n. And the 1 is because, according to Pascal, one can choose to believe in God or not to believe in God, but one has to make a choice, hence the 1. N cannot equal 0 since, according to Pascal, God exists or God does not exist. And in Pascal's wager, he made n equal 2 because he believed that there were two choices, Christianity or atheism, and he deemed that all the other religions were ridiculous. So many people have criticized Pascal's wager because hypothetically, n could equal infinity, meaning that one could create as many religions as they please. And so I've expressed it in limits right here. As x approaches infinity, p equals 1 over n, and so the chances of winning Pascal's wager, p, get closer to 0. So I made a little chart saying the possible outcomes and the odds of winning. So from a mathematical point of view, Pascal would be incorrect, as the odds of choosing no God or the right God makes the odds of winning the wager close to 0. Patterns in Pascal's triangle. Pascal triangles has a lot of patterns, including hockey sticks and the Fibonacci sequence. If you align left the Pascal's triangle, the sum of each row diagonally makes the Fibonacci sequence. So, for instance, the first white number 1 is 1, and then the second pink number is 1. Then the sum of the 1 and 1 equals 2, 2 and 1 equals 3, 1, 3 and 1 equals 5, 3, 4 and 1 equals 8, and so on. I think that's pretty cool. Pascal's triangle of the exponents of 11. The exponents of 11 can be found in Pascal's triangle. For For instance, the 1 is equal to 11 to the power of 0. The 11 is equal to 11 to the power of 1. The 121 is equal to 11 to the second power. 1331 is equal to 11 to the third power, and so on. After the fourth row, though, the numbers overlap to make the exponents of 11. So, for instance, in the fifth row, 1, 5, 10, 10, 5, 1. The 1 stays the same. 5 plus the 1 in the 10 add together. The 0 adds with the 1 from the 10, and then the 0 from the 10 stays there, and then the 5 and the 1, which makes 161,051, which is 11 to the fifth power. Pascal's triangle and Sierpinski. Sierpinski's triangle was created in 1915, but people have found evidence saying it dates back to the 13th century in Italy. It is one of the world's most famous fractals and is infinite. Coloring. As shown to the right, one can use the Pascal's triangle to obtain Sierpinski's triangle by either coloring all the evens or all the odds numbers, but not both. If you ever want to bet money on where the pinball will end, you can use Pascal's triangle to do so. The pegs in a pinball machine can be used to find the probability that a ball will go to any cup, if used with correlation with Pascal's triangle. So for instance, if the 1 reaches the second cup to the left, then there will be 4 paths it can take to reach that. The numbers of Pascal's triangle indicate the number of paths that the ball can take to reach said cup. So for the 2 cups on the outer extremities of the pinball machine, there's only one: scuba diving and Pascal's principle. Pascal's principle is important for scuba divers to acknowledge, as when a diver goes deeper into the water pressure conjointly increases. Pascal's principle can be applied to many other things as well, such as submarines and war machines. Pressure equals force over area. My ears, says the scuba diver, and then the fish responds, your ears hurt because of the pressure. It can easily be applied by the formula P equals F over A, and is the reason that you're making so many bubbles underwater. Here are my sources. The first one is Pascal's Wager, The Man Who Played Dice with God. I suggest it to anyone who's interested in philosophy and even math. It's a really good book. And then the second one is Pascal's Arithmetic Triangle, The Story of a Mathematical Idea. It's really good if you're interested in Pascal's life and all the accomplishment he made. He made many, and he was really a child prodigy. He was brilliant. I suggest it to anyone who's interested. And the last one is Pensée by Blaise Pascal himself. And it's really good. It goes more into depth with Pascal's Wager and how he came to it, along with other principles he invented. So thank you for watching. I hope you enjoyed the video.